So just a quick uh, introduction and mm, a, a quick recap of why for the uh, learners. And since these sessions are will be uploaded in the public forum, welcome to the problem solving session for the course Geotechnical Engineering 1, uh, handled by Professor D.N. Singh from the Department of Civil Engineering, IIT Bombay. So I am Yogendra Narayanan, yes, and I will be taking this session for the 10th week. And these sessions will be conducted on Saturdays at from 5 p.m. to 7 p.m. And those who have registered for this course can participate in these sessions. Uh, and the purpose of these sessions, to reiterate, is to uh, make the learners proficient in the contents of the subject that has been covered in a particular week. So based on these topics that have been taught in a in a week, so a comprehensive picture of those topics in the form of uh, problems that has been asked in the previous assignments and previous examinations uh, will be displayed to solve. And I will be conduct as a person conducting it. I will be facilitating the learners in solving these questions, which makes the learners uh, get accustomed with the type of problems that they might face during the examinations, and uh, follow the right approach in solving them. So with this, I would like to give a small recap of what the course content for the 10th week of this uh, course, Geotechnical Engineering 1, has covered. So essentially, this week lectures started with the stress distribution in the soils, how the external stresses get distributed within the soil mass, what are the various theories that has been employed to calculate this increment in or the distribution in stresses. The theories namely are Boussinesq theory, Westergaard's theory, and several other methods like mm, Newmark's influence chart method, load dispersion method, etc. has been covered, and various practical implications of where these calculations would come very handy for the engineers and uh, in real life has been discussed. So based on these, we will be solving some of the questions today. So this I am moving to the question part. So we'll be starting with some of the conceptual questions to refresh the basics, followed by the numericals. So the first question is fairly simple. What are isobars? So lines having same temperature, lines having same pressure, lines connecting same volume, lines connecting having same water content. Can you answer the question? Am I audible? Hello?
Yes, sir, audible.
Uh, uh, can you can you guess the right answer for this question? First question.
Pressure, same pressure.
Yes. So this uh, Isobars are lines connecting the same pressure. So this is the right option. And having same
Good.
temperature we call as, what do we call? Any guesses? Hello? Hello? Am I audible or not?
Yes, sir, audible.
So what do we call the lines connecting same temperatures?
But its voice is breakdown.
Hello? Now is
Yes,
it
sir.
audible? Now is it audible?
No, sir. Voice is breakdown.
Okay, just a minute. Is it now audible? Hello?
Yes, sir, it's audible.
Okay, can you say um, the lines connecting the same temperature? What do we call?
Same temperature. I don't know. I don't have any idea, sir.
Okay, so these are known as isotherms.
Isotropes.
Terms.
Isotope.
So this is isobars. So line connecting same pressure or same quantity, whatever we call, and if these are in general terms we call as contours. So the lines connecting same points having same quantity, in general terms we term as contours. So the questions can be like this also: contours having same temperature, contours having same pressure. That also means it is isotherms and isobars only, right?
Contours means same temperature and same pressure.
No. Contours generally means same value of something. Line
Same
connect
value of something. Same volume, same water content.
anything, same elevation, same height, everything.
Okay,
Uh,
that are called contours.
General terminology is contours.
Okay, okay.
And uh, coming to the next question, which of the following is not an
Sir,
as
same volume, what's called?
no same these C and D are just an option. They don't essentially mean anything.
Okay, okay, sir.
Uh, Volume, uh, currently I don't remember. Maybe I can check and tell. And water
Okay, sir.
content also, I'm not recalling right now. Maybe I will check and tell in the next week.
Okay, okay,
Uh,
sir.
so coming to the next question, which of the following is not an assumption associated with Boussinesq's theory?
Yeah. The weight of the soil is considered, that is no.
Okay. So first of all, first option is soil mass is homogeneous and isotropic. This is obviously an assumption in majority of the problems that we deal with. Hereafter also many topics, especially compressibility, shear strength, everything will be essentially we will treat this as homogeneous and isotropic. And B is elastic and semi-infinite. So elastic we know, Elastic, what does elastic means? Stress is directly proportional to strains.
Strain.
So stress is directly proportional to strains. Sigma directly proportional to epsilon. So that is under a particular limit. So this is what law?
What?
This is Hooke's law.
Hooks.
Hooke's law. So within the elastic limit, stress is directly proportional to the strain. So this is Hooke's law, and hence obviously Hooke's law is also valid. Be elastic. What does semi-infinite means?
Semi-infinite means x direction and y direction is infinite, but z direction is finite.
Yes, exactly.
But in the
So
lecturers are told z direction is also infinite.
yes, actually semi-infinite means you have uh, three axes. So this might be x, this might be y, and this might be z. Any in a particular direction, you are restricting, or there is a measurable uh, quantity. So in any direction, whereas in other two axes, it is infinite. So that is known as semi-infinite condition. Right. In this case, generally, in soils, we assume the lateral extent. This is if we consider this as ground, right?
Yes.
So in this direction also it is infinite. In this direction is also it is infinite. Whereas here the extent is infinite, but the value we consider is we are choosing here, right?
Yes, sir.
So that is why that is the notion. It is known as semi-infinite. So z is finite in this direction. Is it clear?
Yes, sir, it's clear.
So this part is also right. Now coming to the fourth option, weight of the soil mass is considered. So weight
Ne-
of the soil mass is a
neglected.
property of the soil which depends on its density. So essentially, Boussinesq's theory, or for that aspect, even Westergaard's, Newman's influence chart, any theory does not consider material properties at all. It is blind of material properties. Whereas Westergaard's, they consider material property in terms of Poisson's ratio. So in these conditions, when in case of Boussinesq's theory, the material property is not at all coming into picture. Hence, this this assumption does not come into picture. Hence, this option is the right option uh, for this question. Okay. Hello.
Yes, sir. Okay,
Am I
sir.
audible?
Yes, sir, it's audible.
Okay. Now moving to the next question. So uh, now consider look at the first question. Vertical stress variation with depth at a radial distance r from the point load increases with depth, decreases with depth, first increases with depth and then becomes constant. First increases with depth, then reaches a maximum value, and then again decreases.
Take cost of direction. Take depth that will have to be calculated. Sir, I don't have any idea, sir.
Okay. Now, if you consider a ground and you are applying a point load, now two conditions you can take. Now you take at a particular depth Z, and at a particular radial distance you take one R. So this is Q. If you consider this, generally the variations will be with at a particular Z, the variation of it will be like this. So beneath the loading point, the applied stress will be higher at a particular Z. Either side it will be since it is a if we can it is a symmetrical condition, either side it will be decreasing, whereas for a particular R at Z it will increase like this and get like this. So first increases with depth, reaches a maximum value, and then again decreases, but it will not touch the zero, so it will be asymptotic. Okay.
Okay, sir. But in horizontal,
Yes.
ho- how, sir?
Horizontal also, see, you have to consider two different cases. Now first you consider at a particular R with depth, so that is this variation. Okay. Now for a particular Z with R, so this is also one type of variation, so this follows this one. Now a simple way to understand this is, you take various values of R and Z,
Okay.
and you apply Bossinus theory, and you get the values for different R and Z, and you plot and see.
Okay, sir.
Okay, in terms of coordinates you can plot and see. So if you consider this as 0 application point as 0 comma 0, Bossinus theory is not valid for Z equal to 0, that is at the point itself, right? What is the formula for Bossinus theory? Sigma Z is equal to
3 by 2 pi
3 by 2 pi q by
q
z
by z
square,
square
now into
1 plus
or otherwise
influence factor.
in simple terms it is influence factor,
Influence factor.
IB. So what happens when Z is equal to 0? Sigma Z tends to infinity, which is not possible. So this method, that is Bossinus theory, is not valid for Z equal to 0. But Z equal to 0 means at the ground level, right?
Yes, sir.
So apart from ground level, you take some values and try to plot and see. So then you will get a idea of how stresses are varying.
Okay.
Okay. So the right option will be this one.
Sir, if Z tends to zero, what happens?
Sigma z will tend to infinity, na?
Yes, yes.
So in that case, what will happen? Here you cannot apply it at the point, that is z not tends to 0, z equal to 0.
Hmm.
So at z equal to 0 it will not be applicable. So that is the case, so this will be the right option. So coming to the next question, a square column sized 3 meter by 3 meter is carrying a load of 5 meganewton. So what would be the stress at a point 4 meters below the footing? Consider angle of dispersion to be 30. Can you solve this question?
No, sir. I will try.
So first what you will do? Hello?
Yes, sir.
First what you will do?
Q is there.
What value have been given? Load is given, capital Q,
Yes, sir. Load is given.
5 meganewton. So
Yes.
what method we have to use here?
So, Bosnia's influence, Bosnia's
Bossinus
theory,
Bossinus
dispersion
theory,
to angle. So,
angle is given.
okay,
So it will be load dispersion method,
okay.
right? Now if you take a now you just try to conceptualize the question. So this is the footing, right?
Yes, sir.
Its width is 3 meters, right? So and the load applied is 5 mega newton. For just uh, okay. Hello.
Yes, sir.
Okay, this is the actual condition given. Now what you have to find at z you consider this is at the ground. This is ground level, right?
Yes, sir.
What depth do we need? At
4 meters.
4 meters. Now you have to, this 5 meganewton is the load. Now you have to calculate the stress acting on the footing. How will you calculate?
Consider the angle of
Small
distribution.
q is equal to, let small q be the stress acting on the footing itself. See this, listen carefully. This is load, force. You have to convert into stress.
Okay.
What you will do?
By area, load by
Yes,
area.
first step is you have to convert this load to area, stress. So always look for this. Uh, Always be careful and make sure that in what uh, units they have given, whether they have given it in terms of load or whether they have given in terms of area. So now when you calculate 5 divided by
9.
3 into 3, how much you are getting?
0.55.
0.55 unit
Meganewton per meter square.
megapascal.
Newton per meter square.
You can write as megapascal, right?
B.
Or
Okay.
you can write as 550
Kilonewton per meter square.
kilopascal. All right. Now
Yes.
you know the stress. Now what they are saying, consider the angle of dispersion to be 30 degrees. So the stress acting will be dispersed like this. Dispersion in the sense, here it will cover a even more higher area, right? Now what will be the new corrected area? Now sigma z equal to q, or uh, what to say, you have to, this is the q acting at the uh, how to say it, acting at the footing. Hello,
Yes, sir.
am I audible?
Yes, sir. It's audible.
Okay, now just a minute. Is my slides visible now?
Yes, sir.
So now you know the stresses acting at the footing. Now this load will be acting due to the dispersion, they will be acting at a even higher area, right? Now you, for comparison sake, we will calculate, we have this stresses. Now sigma z, you will be uh, what will be the formula for it? Now you consider, let us consider this as x. This is the same x. So this is 30 degrees. So this is 30 degrees, right? Hello,
Yes, sir.
am I audible?
Yes, sir. It's audible.
So are you able to understand?
Okay, sir. Understood.
Now you will be dispersing it. Now you know this length is 4. So what will be x? X by 4 is equal to
Sin 30 into.
tan 30.
Sorry.
So x will be
Okay, okay. Tan 30.
4.
4 tan 30.
How much you are getting?
2.309.
This 2.309 meters either side.
Yes, sir.
2.309 meters. Now corrected area is Q is 5 meganewton, which we can convert into 500 kilo 5000 kilonewton divided by area. area is, since it is a square, that in that direction also same dispersion will be there, right?
Yes, sir.
So what will you do? 3 plus
3 plus 2.309 plus
2
2.
into 2.309 whole square, right? So 2 means why we are multiplying it with 2. This side also it is extending by 2.309. That side is
Yes,
also it is extending by 2.309.
yes, sir.
Now you calculate this.
58.03.
Okay, now it is 58.03
Zero 3.
kilo Pascal.
Not total value, sir. Wait, wait. Wait.
Oh, you
Only
calculated properly.
total value is 86.156.
Yes, 86.15
156.
kilopascal. Now you are able to see, right? See, when the depth is increasing by this method from 550 kilopascal at this stress, it is the amount of stress that is being experienced by the soil here is only 86.15 kilopascal.
Yes, sir.
So this is the value. Now you calculate what the value will be if this person is 45.
45 is equal to 1030.
No,
10.
angle of dispersion is 45.
Okay, okay. 1045 1 కాబట్టి 4. So 3 plus 7, 7 plus 11, 11 square, 21, 41.32.
It is 41.32. So generally what we will do is, this is a special condition. Generally the slope we take is, for every 1 meter horizontal length there will be 1:2. This is the slope we take. Yes, hence this method is also known as 1:2 method. Right? So hope it is clear now.
Sir, in the
Yes.
sum, what we would be stress? Stress means which uh, which stress we.
See here, the reason why I calculated stress at footing is to get a benchmark value.
Okay.
Now always see here what happened here. You are calculating at the point of application or the platform at which the load is being applied. So for that you are calculating an area 5 by area is 3 by 3, right?
Yes, sir.
Now due to, when as the depth increases, this stresses will get dispersed in both the direction. So how it will get dispersed is by angle what they have given is 30 degrees.
Mm-hmm.
So
Okay. Sir.
uh, so what does that mean? So the area for which the stresses are acting is higher compared to the actual platform area. So that is why the area is getting increased, hence the stress intensity is getting decreased.
Okay, sir.
Is it clear now?
Yes, sir. It's clear.
Okay. Now let us move to the next question. So if a point of 100 kilonewton is applied on the surface of ground, what would be the stress at the point 3 meter directly below the load application point? So it is a fairly straight question. They have given Q, which is 100 kilonewton. They are asking sigma z at 3 meters, which you will be calculating by Boussinesq theory, 3q by 2 pi z square, 3 into 100 divided by 2 pi into 3 meter is 9. So here you will be putting 100 by 6 pi. What value are you getting?
5.305. Sir,
Yes.
2, okay, okay, 6 and 5.305, sir.
100 by 6, 16, 16 by 3. Okay, 5.305.
5
What is the unit?
kilonewton per meter square.
It is kilopascal. So you have to be careful when you use Boussinesq theory. You will introduce in terms of load, and you will get the outcome as the stress. So you have to be careful on it.
Okay, here the radial distance is not given, so we take 0.
R is 0.
Okay, okay, sir.
So coming to the next question. So 50 kilonewton point load acts on the surface of an infinite elastic medium. What will be the vertical pressure in kilopascal at a point 6 meter below and 4 meter away from the point of load application? Now what you have? You have Q is 50 kilonewton, R is
Vertical pressure.
4 meters, Z is 6 meters. So by using Boussinesq theory, sigma Z at R is 4 comma 6 is equal to 3q by 2 pi z square into 1 by 1 plus r by z whole square whole power 5 by 2. Calculate and say how much value you are getting.
Okay, sir. 0.264.
0.
264. Oh,
It is 3 into 50 divided by 2 pi into z is 36. Just a minute, we will just cross check it.
okay, sir.
This 6. How much you are getting? Point
2644.
2644.
Yes, sir.
350 6 meter depth, 4 meters. Okay, point 26 na.
Yes, sir.
So similar to the next question, similar to the previous question, same, only values are changed. So you can calculate this easily. 3 into 100 by 2 pi into 9 1 by 1 plus 2 by 3 square. How much you are getting?
Great, sir. 2.11.
Yes, 2.115, which will be approximately 2.12 kilo Pascal. So now you come here. So a concentrically loaded isolated square footing. So square footing is that platform, square platform of which 2 meters carries a load of 100 kilonewton. By using Boussinesq's theory, the maximum depth corresponding to 10% of the stress intensity will be. So now here you can assume that R is equal to 0. Can you solve this question?
I will try, sir.
Okay. Did you get the idea to solve it? Hello?
10 percentage of the stress intensity will be what?
So for that only, uh, okay, now what you have to do is, what is the stress intensity formula?
Stress intensity formula 3q by 2 pi z square.
TQ by 2 pi Z square. Now here, sigma Z, so now you have, what you have? You have the load Q, right?
Yes, sir.
And you have width.
Depth.
Width also you have.
Okay, okay.
So now you can find the stresses, right?
Okay,
Q is
sir.
equal to Q by B square, right?
Yes.
Okay.
Only with this is strip putting.
Not strip, square footing, na?
Yes, sir.
That's why B square.
You okay,
If it
okay.
is strip, we will be dividing by only B. So just listen here. So Q is, let small q is equal to the stress acting at the footing, right?
Yes, sir.
For how much, this is the total stress intensity. So for how
So
much,
10%. Okay, okay.
yes, any question?
No, no, sir.
Now you need to find the value of Z at 10%, that is 0.1 q. Now you substitute sigma z here. 0.1 q is equal to 3q by 2 pi z square. Now here you substitute 0.1 into q will be q by 4 is equal to 3q by 2 pi z square. Now q and q will get cancelled. 2, this 2 will get cancelled. Z square is equal to 60 by pi. Z is equal to root over 60 by pi. Are you able to understand?
Yes, sir.
Are you able to understand how we are taking 10% of the stress intensity?
Yes, sir. Understood.
You know what value you are getting for Z?
Hmm.
What value are you getting?
Sir. Wait, wait. 4.3.
4.3.
4.37 meters.
So 4.37 meters. So this is the value at which 10% of the stress intensity will be acting. Right? Any doubts?
Sir,
Hmm.
if so how uh, ఎలా 10% is of the stress intensity, so you take the q is equals to q by b square. So how
Yes.
to know, sir? Ante sigma z, suppose sigma z is equals to, that is also stress. So we
Ah,
calculate that one. So
no,
we
no,
take.
no. Just what I am trying to say is, so you just for to see sigma z is 10% of something, right?
Yes, sir.
So that is I am just giving it a name small q. So that q you it is given in the terms of load acting in a on a footing. So how
But we don't give 10% of the stress, which is equals to sigma z.
I'm not getting your question.
In that sum, we only give 10% of the stress.
Maximum depth corresponding to the 10% of the stress intensity.
Yes, sir. So 10% of 10% of Q. Q means where stress, pressure, both are.
See, let me explain. I got your confusion. So first you conceptualize this question. So it is a 2-meter footing.
Yes, sir.
It is acted upon by force of 1000 kilonewton. Right?
Mm.
Now 10% of stress intensity will be here some stress will be acting.
Mm.
How much it will be acting? 1000 divided by 4.
4 meter square.
It will be 250
250. Yes, sir.
kilopascal. So this is the actual stress intensity.
Okay.
So what we are asking is at what depth this 250, 10% of 250 will be acting.
What was it again then?
What is the depth at which 10% of 250 will be acting?
Okay.
So for that, what you know from Bossinus theory, you cannot take stress directly. You have to take the load.
Yes,
So
sir.
this part you are trying to convert in terms of the actual stress uh, that is being experienced at the ground.
Yes, sir.
So this I am just assigning a value q,
Yes, sir.
right? This q at what z, at when sigma z is equal to zero point 0.1 times of q, z is what,
Okay, sir.
right? So it is just, if you consider normal condition, in a straightforward question you will be calculating sigma z.
Okay.
Now I gave you sigma z indirectly.
Mm.
You have to calculate z. So it is a uh, reverse calculation.
Okay, okay, sir.
Okay. So
Mm.
that part, that is what I was trying to emphasize, right? Now you
Yes,
got it or not?
yes, sir. I got it.
So the person who joined now, uh, you can you can join from the next question in solving, and previous questions will be uploaded in the public forum in your NPTEL account. There will be an option of problem solving sessions 2000 January 2024. In that you can find the slides as well as the video links of this session. in which you are attending, and whenever the problems that is being solved, I would expect you to also solve the questions and be interactive. So then only I can understand whether you are you are able to solve the question, or you are facing any difficulties. If you are facing any difficulties, don't hesitate to interrupt me. You can interrupt me at any time. So moving on to the next question. So now, in the construction of Newman's influence chart, the number of annular areas are 10, and each is divided into 20 sectors. What would be the value of influence factor? How will you calculate the influence factor here? Any ideas?
M by M, 1 by Mn.
It is 1 by Mn. So influence factor is 1 by M into N. 20 into 10. It will be 0.005. Right.
Yes, sir.
Now, what is the physical significance of it? So you are directly giving IF. You are directly saying 1 by M into N equal to, you are substituting the values. What is the physical significance of it?
Physical significance means where M, what is M?
Yes. Why we are arriving at an influence factor of 0.005? So to understand that, you have to go back to the steps by which Newmark's chart is constructed. So
Yes, sir.
Newmark's chart is essentially constructed using assuming circularly loaded area.
Yes, sir.
So in this, what we will do is we will be dividing this area into 20 parts. We will be dividing into 20 parts. All right. So that is 20 here, right? Okay. Hello.
Yes, sir.
So you will be dividing the circle into 20 parts.
Okay, sir.
So that is given by M. Now 10 is, you will be constructing 10 concentric circles. Like this, you will be constructing 10. So just for the sake of drawing, I'm just drawing it. So you will be, that is, you will be constructing concentric circles such that there are 10 areas, 1 2 3 4 5 6 7 8 9 10 up to this. So when the entire influence is 1, what will be the influence of only this part?
1 by Mn.
1 by 20 into 10. So generally what they will do is if you have a loaded area, now you consider any loaded area like the shape of it, in which uh, load you know the stresses acting. Let us say 150 kilopascal is acting on it, right? Okay.
Yes, sir.
Now what they'll do is they'll take this area, the same area, and they will superimpose here. They'll just do they'll just superimpose like this. So to give a distinction, I'm just giving this area, they will superimpose here. And you know the influence factor for one 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 segment, right? Hello,
Yes, sir.
are you able to understand?
Mm.
So the other person, are you able to understand?
Yes, sir.
So you will be superimposing this loaded area like this. Now the required stress intensity sigma will be number of segments that is covered into the influence factor for one segment into the stress acting in it, total stress, that may be Q. So this is how the distributed stress is calculated. All right. So now having this background, you try to solve this next question. A Newman's chart has an influence factor of 0.01. When plan of circular footing is superimposed on the influence chart, the number of sectors occupied by the footing on the chart was found to be 15. Then what would be the stress at the point of interest if the footing is carrying a load intensity of 1500 kilopascal? Can you solve this question?
Yes, sir. Yes. N into IF into Q.
Yes. So sigma will be n into influence factor
225.
into Q. Here n will be 15, IF will be 0.01 into 1500. It is effectively 15 into 15, which is 225. What is the unit?
Kilonewton per meter square.
Kilopascal.
It is kilopascal. So always make it a practice to say the value along with unit. So moving to the next question. So the change in the vertical stress in the soil mass estimated by Boussinesq's equation when Poisson's ratio of the soil changes from 0.25 to 0.4 will be. So what will be the answer for this?
Change in vertical stress and Poisson's system.
Did you get any idea how to solve? There is a trick here. So carefully see the question. If you catch the trick, let me know.
Bosner's theory not depending on the Poisson's ratio.
So any other answer? The other person, Mr. Rahul.
No idea.
So what does Bossinus theory's assumption is? It does not take into account
Weight of the soil.
weight of the soil, and the not only weight, does not take into account material properties.
What does not into account?
Material properties, any material properties. It is purely mathematical and geometrical. So material properties include Poisson's ratio, elastic modulus, Poisson's ratio, strains, uh, etc. Mineralogy, water content. It does not take into account any of the material properties. So change in vertical stress in the soil mass estimated by Bossinus equation, hence Poisson's ratio of soil changes will be 0. It is blind of material properties. All right. Is it clear or not?
Okay.
Sir, where zero means does not change.
Does not change. Change is 0.
Okay.
So I hope this is clear. This question is clear.
Sir.
Yes.
Right. Now, moving to the next question. So a uniformly distributed line load of 500 kilonewton per meter is acting on the ground surface. Based on the Bossinus theory, what will be the ratio of vertical stress at a depth 2 meter to that at 4 meter directly below the load? So what they have given? They have given R is equal to 0, Z1 is 2 meters, Z2 is 4 meters. What they are asking is sigma Z at 2 meters by sigma Z at 4 meters. Right. They are asking this only, right? Now here you have to consider two important points. So first point is it is a uniformly distributed line load. So it is not point load. So Bossinus theory has to be modified for line load. So this expression for line load will be sigma z is equal to 2 q by pi z 1 by 1 plus r plus R by Z square into whole square. So how much you are getting?
4,
So you are getting 4. The other person?
4, 4.
Yes, yes.
Not solved, sir.
So solve it quickly. Let me know the answer. So here Q you have to substitute it as directly 500 kilonewton per meter.
Okay, sir. Two times, sir.
2 times, so R is 0,
Yes, sir.
2Q by pi Z. So it is essentially dependent on Z.
2 by cancel.
So Mr.
By
Rahul,
total.
you have to check the answer.
Okay, sir.
No, it is inversely proportional to square of the depth. Stress
That,
is,
see, that is direct Boussinesq theory for point load. So this is line load. Line load, it is directly proportional to inverse of Z only.
oh, sorry. I thought, took it for point load.
Yes. So when R is 0, it is sigma Z is directly proportional to 1 by Z for
1 by Z.
line load.
Oh, yes, yes.
So you will get 2. Now you calculate the same ratio at R is equal to 3 meters. When R is equal to at R equal to 3 meters, what will be the ratio of it? Calculate it faster.
3 by 2.
See here R by Z, it will get changed. You can just check it once. So let the other person also solve. How much you are getting?
0.96.
Okay. How much you are getting? Sigma Z at 2 meters will be, let us ignore this completely. This will however get cancelled. So it will be 1 by 2 into 1 by 1 plus 3 by 2 whole square, the whole square, divided by 1 by 4 n plus here it will be r is 3 by 4 whole square, the whole square. So when you do it, it will be 2 times of how much you will get the first one, that the term in the bracket in the numerator, 1 divided by 1 plus 1.5 square
చెప్పాలా ఎవరైనా
or
దగ్గరికి వెళ్ళిపోతే కనిపించట్లేదు
equal
కనిపించట్లేదు
0.09. Similar way you will be getting, sorry, here it will be 1 by here you will be getting,
సార్
yes,
your writing screen is not visible, sir. Screen is visible, so what you write, that is not visible.
entirely is it not visible or
Only your right, when left, right side, so your writing screen is right side, so that is not visible out of the
It is visible.
screen is visible.
okay, hello, is it visible or not?
Visible.
Okay, so now it will be, this is 0.09, just cross check this value, the term here, this term, and in the same way calculate for numerator also.
ఓకే ఓకే ఇక్కడ స్క్వేర్ ఇక్కడ స్క్వేర్.
The
0.46.
0.0473 numerator.
this one
Numerator.
entire this part na,
Numerator. Only numerator. Full value.
okay, okay, 0.0473,
0473.
all right. So denominator will be
0.1024.
0 point, yes, will be 1024. Now you calculate the
0.46.
will be, that is the ratio 0.46.
Yes, 0.46.
All right, so now it can, now one more thing can be extended. If this ratio is 1, all right, what will be the value of r? Can you try this? Is it possible? Is it possible to get a unit R value?
Possible.
How is it possible?
Only unknown is R.
So if you do it by uh, Z, okay, try it. So it will be 1 by 2. It will be Are you following?
It's a imaginary values.
How it is imaginary?
Answer is negative root over minus root over negative value.
Root, it should not come, no? It will not come. Are you getting this expression? Is anyone getting this expression? Hello? 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 Are you getting this expression? Please respond.
No, sir.
The other person? So Rahul.
It is coming in terms of 0.25 r 4 r square 56 something.
So where Acha, you did not take square root on both sides initially.
Initially I have taken squares.
Okay, you have taken squares. So are you able to solve that equation?
No, it's no.
That
The
r,
simplified version I have written in the chat box.
yes. So you substitute r power 4 as some x square and r square as x, and you try to solve it.
R square as
R square as you consider r square is equal to x,
okay.
and if you substitute it, you will be getting a equation in terms of quadratic equation. Then you might, if you have a calculator, you can solve in calculator also.
Mm-hmm.
The answer is Sir, 1.60.
Okay. Let the other person also solve. What is the equation you have given? 56 plus 4r square minus 0.25 r power 4 is equal to 0. Now this can be written as 0.25 x square minus 4x minus 56 equal to 0. Okay, R will come around 1.602. You can check these values from the, you can try resolve this problem. So due to the time constraint, I'll be moving to the next question. So let us solve this problem now. Are you able to see the slides?
Yes, sir.
So there are 4 point loads: 1000 kilonewton, 800 kilonewton, 600 kilonewton, and 400 kilonewton, arranged in the given arrangement, right? Now you calculate uh, first. Let us now you calculate the sigma z, right, at z equal to 3 meters. All right,
Yes, sir.
beneath C point, below C point. Remember the concept of superposition. Superposition was taught, na? Hello?
No, sir.
So how will you calculate here? So I will just give you a hint here. So you can solve, you'll be able to solve. So you have to calculate stress at 3 meters from C, right? Now the general formula is sigma z is equal to 3q by 2 pi z square, 2 pi or pi, 2 pi z square 1 by 1 plus r by z whole square whole power 5 by 2, right? Hello,
Yes, sir.
Yes, yes, correct.
right? Now you need to calculate under C, but there are, apart from C, if there are no other loads, you will be directly using this single formula and you will be calculating, right? Now there are three other loads apart from load acting at C. So how will you calculate? You have to calculate 4 times. So first one is under C itself, for which you will get QC by 2 pi z square plus, this is uh, for simpler, for your understanding, I will just write. So sigma z at C is equal to uh, how to put it? Uh, let us so let me write sigma resultant at C equal to sigma z at C due to A plus sigma z at C due to B plus sigma z at C due to C plus sigma z due to sigma z at C due to D, right? Hello,
Okay.
Okay, sir.
are you able to understand or not?
Yes, sir. Understood.
Yes, yes.
Now what you have to calculate is, you calculate the value for, the value of z is 3, that is constant, right?
Okay.
Now the value which is going to change is r. So r a to C is equal to how much? This distance,
4.224.
it is
Root
it is
of 18.
just Pythagoras theorem, 3 square plus 3 square, which is 18, 4 point something, 4.2 or something, right? First I wanted to know, are you understanding this terminology, why we are using this?
Resultant.
So apart from, you want to calculate at C, so apart from load acting at C, you have loading acting at A, B as well as D. So you will have the influence of these three loads on this point also, right? To
Yes.
understand these influences only, we are directly adding the stresses by taking into account the radial distance r.
Okay.
So here r AC will be 4.2 or something. Now what will be the distance B to C? This obviously 3, and C to D is 2,
2.
and For C, R will be 0. Here, R will be 4.2. Here, R will be 3. Here, R will be 0. Here, R will be 2 meters. Now, can you calculate this?
Okay, sir. $3.41.
Now, you take this entire 3 by 2 pi z square as common. So, what is the value you are getting here? This value. There will
It's our
be
overall answer.
1000 into n by 1 plus r is 4.2 by 3 whole square for 5 by 2 plus, if you take 200 as common, this you will get as 5, this you will get as 4 n by 1 plus 3 by 3 is obviously 1, 5 by 2 plus this will be 0, sorry, plus it will be as for 1, that is 3 plus 2 into 1 by 1 plus 2 by 3 square power 5 by 2. Are you able to understand?
Yes, sir.
So now you say this terminology, this term, value of this term. Obviously, we can cancel this,
3.41.
and this we can cancel 9. It will be 100 by 9 pi. Eighty-seven, 3.5.
3.41.
5.
Divided by 9 pi. 3.53 will be 3.53. What is the value of this first term? 4.2 divided by 3 whole square plus 1 will be 0.332 plus 0.5 power 0.5 0.707 plus 3 plus 3 point 793. So if you add this 0.798 plus 3 plus 0.707 plus 0.332 into 3.53, you will get approximately 17.07 kilonewton per meter square.
Sir,
Yes.
I solved individually and adding 51, I think 51.20.
Yeah, yes. 51.2.
Okay.
Stress intensity at A is 3.5. At B it is coming 7.495.
Okay.
At, at C it is coming 31.8.
Mm-hmm.
And at D it is coming 8.39. So together we add it's coming 51.2.
51.2, right?
Yes,
Uh,
sir, 51.2.
just a minute. 100 by, sorry. If you see here, this is 3 and this will be 3 times. So when you do it, 100 by 3 pi. So 100 by 3 pi, if this has to be multiplied with 3, because earlier I had taken 100 by 9 pi. So that is a calculation mistake. So it will come here 51.2. So that is the right option. So now coming to the last question. So now you have uh, just a minute. I have done a mistake. Are you able to see the figure?
Yes, sir.
Yes.
Okay. Now this is one of the problems. Do you remember that one method is there using m and n? M is equal to b by z, n is equal to l by z.
L by Z.
This method, na, this problem has to be solved by this method. So you need not remember the big formula here. I have provided the chart here for the particular value. So while if and then when it is required, we will be using these values directly. All right. Now this is one of the most easiest and also most trickiest method. uh, Now you have been given a area and you have to calculate at 2 points, one is at C and one is at B, right? So first we will calculate at C. All right. So hello.
Yes, sir.
Am I audible?
Yes, sir, it's audible.
So we will calculate at C. Now what is the value? Sigma will be some influence factor into Q. Q is 100. Now our main motto is to find IF, right?
Yes.
Now how will we do? So here let us give the names here. Uh, let it be how to put it. So already A, B, and C are taken. Let us give the names at the edge of the triangles. A is. Are you following, or you are facing any confusion?
No, sir. Tell me.
Okay. Now let this point be A, and B, C are already taken. Let this point be D, and let this point be E, and let this point be F. Okay. Now you need to calculate the stress increment at this point. Now what I'm doing is I'll just extend this rectangle by such that this corner of the rectangle is placed at C, right?
Okay, sir.
So let me give a point F dash here. So at sigma Z at C, how will you calculate the influence, what to say, load, that is sigma Z at C is sigma Z due to the entire rectangle C D E
Yes.
F dash
Yeah. Okay.
minus
Sir,
sigma Z. Yes.
the ACFF dash, no?
Let me
What?
come. Let me complete.
Okay.
Now sigma Z A C F F dash. Right. Now what I'm doing is I'm taking the entire rectangle and I'm subtracting this from the entire rectangle. All right. Are you able to
Okay.
understand, or you are face where you are
So we
facing?
get the rectangle ADEF.
See, that's what I'm saying. Now you have the rectangle ADEF, right?
Yes, sir.
Now what I'm doing is I'm extending this rectangle such that it becomes CDEF dash.
CDEF dash. Yes, sir.
Now, but I am considering it, initially I'm considering it as completely loaded, but actually out of that entire rectangle, this portion is not loaded, right?
Okay.
So what I'm doing, in completely I'm considering this and I'm subtracting this part only.
Okay.
Are you getting, Mr. Raghu?
Yeah, yeah. But what is the
So
reason in considering extended portion and then again subtracting?
yes, so as far as this method is considered, you have to place the point in which at which you have to calculate the stresses as a corner of the rectangle.
Since the point is outside the rectangle, so we have extended.
So you have to extend such that one rectangle is there as a corner. That
Acha.
point is a corner to the rectangle. So then only
O-
this method is valid.
Okay, okay.
Now first you consider, you calculate, you let us take this case. Now IF into Q is 100. IF is, let me first you calculate M and N. M is B by Z, N is L by Z. How much you are getting B by Z? Now what is the b value? B value will remain same. It will be 2 by, let us say, z at 2 meters. So m will be 1.
And what is B? Can you please explain?
B is the width. Width will always be the shortest dimension,
Acha, acha.
and L will be the longest dimension
So
of the
Z is
rectangle.
assumed here.
Hello?
Z is assumed.
Z is depth. I am giving it as 2 meters depth.
Okay.
Okay. Z is now for length will be 4 plus 1.2, which will be 5.2 by 2. It will come almost 2.6.
Sir,
Yes.
their length is equals to which length? Okay.
Entire rectangle na 4 plus 1.2.
Okay, okay.
Now similarly, you calculate for this part. You are getting m will be same, n will be 0.6. Sorry, here you have to be careful. In this rectangle, the larger portion is L will be how much?
2 meters.
L will be 2 meters. So this will be 1, m will be 0.6. Always remember B, in the sense it is the always the shortest dimension of the considered triangle, and L is the larger dimension. Now you have m value mn for both the conditions. Now this is the chart. So first condition is m is 1, n is 2.6. Second condition is m is 0.6, n is 1. Now you take the chart here. Now you have x-axis. Are you able to see the chart?
Yes.
Now you have m as x-axis, if as y-axis, and the what to say, the contours are for n. Now first you consider m is 1, m is 1, and n is 2.6. 2.6 lies between somewhere here. Let us consider for simplicity case, let us consider n as 2, because 2 and infinity does not have much difference. So if you consider 2, draw a line such that it meets this is the n equal to 2 line. Are you able to understand?
Yes, sir.
So the corresponding I value will be approximately 0.2, right? Please let me know if you have any confusions. Am I clear? Are you able to understand?
Yes.
Yes, sir.
Now next part is m is 0.6 and n is 1. N is 1 is this line. All right. Now m is 0.6 means this is 0.2, 0.3. This is 0.2, 0.3, 0.4. This will be 0.6. So now you draw a straight line here. it is meeting here, then you draw a straight line here. Now if you take this, it will be approximately 0.15, right? Now you substitute here 0.2 into 100 minus 0.15 into 100, which you will be getting it as 20 minus 15, which will be 5 kilopascal. All right. Are you able to understand?
Yes.
Now, what will you do for the point B? I'll just give you a hint. You can try it on your own. So divide this square itself into 4. Right. Now you have to let us divide this. Let us name it as this is 1, this is 2, this is 3, and this is 4. The total stress will be at B will be combination of sigma Z1 plus sigma Z2 plus sigma Z3 plus sigma Z4, right? Since the point lies within the rectangle which is entirely loaded, so you have to add every region. So here this region is empty, so we subtracted. Now this point is within the loading region, so hence we have to add these 4 rectangles. Now for one, you have B is 1 meter, L is 2.4 meters, and for this 2 you have B is 1 meters, L as 1.6 meters, same 2 and 4 are same. Sorry, 2 and 4 are not same. This is 1.2 meters. This is L will be 1.2 meters. Sorry, B will be 1.2 meters. Sorry for me. Are you able to understand?
Yes, sir.
B will be 1.2 meters. L will be 1.6. Same here. And for 3,
B is 0.8 and L is 1.6 for 4.
yes, B is 0.8,
And L is 1.6.
L is 1.6. If you come here, B is 0.8,
8. L is 2.4.
L is 2.4. Now you have the chart. You can calculate M and N, and you can add these 4 and you will be getting the values. All right.
Sir,
Yes.
in exam point of view, we అంటే how to find IF value. Now you give the graph.
In exams, either you will be given directly I value or you will be given the chart.
Okay, okay, sir.
That you need not worry.
Okay, sir.
Okay, this part I am just exposing you to solve the questions in this regard.
Okay, sir.
So I think the time is over now. So the remaining questions you can try. It is fairly simple and it is of the same models which we discussed in this session. So with the next week's content, we will be meeting on next Saturday, that is 7th of April, sorry, 6th of April. at 5 p.m. From 5 p.m. to 7 p.m. So these slides you can find in your NPTEL portal. And Mr. Rahul, you have joined late, so you can try the previous problems also from those
Oh,
slides.
okay, okay.
Okay. So I am closing this session. Thank you. Thank
Okay,
you all.
sir. Thank you, sir.
Thank you.